we started off this topic already. Okay, this is not the first lesson. Okay, so what are we doing today? We're going to look into properties of acid, including reactions with metals, alkalis, and carbonates. Okay, then word equation, extremely important. You are not required to write down the chemical equation, but you must know how to write word equation for the reaction. Then state uses of commonly used acids. State the type of acid found in everyday life. Right, so this is what we have for apples, right? Okay, there is this substance called malic acid. Vitamin C, okay, is actually ascorbic acid. And then milk, right? You have lactic acid inside. In case you don't know, so now you know. And then car batteries also contain acid. Car battery is a very big one. Yeah. So if you have seen this before, this is you should be familiar how it looks like. Inside this heavy battery, it contains sulfuric acid. Fizzy drinks, if you like to drink Coke, root beer, Pepsi, Sprite, 7-Up, the gas inside is actually carbon dioxide. And carbon dioxide dissolves in the water to form carbonic acid. That's why when you drink a lot of fizzy drinks, okay, it's not so healthy. One thing is the level of sugar. Another thing is the amount of acid that's found inside. It can corrode your teeth, right? I have also read articles before. People who commit murder, they actually try to dissolve the body in Coke. Yeah, quite scary, yeah, because Coke has the acid. It slowly will actually eat away, right, the remains of the dead bodies. Now, vinegar contains ethanoic acid. So the salad dressing that you have, if you go and read the food label, you will see that the contents, right? One of the content is actually vinegar. And vinegar is also known as ethanoic acid. Citrus fruits, lemons, limes, oranges, contains citric acid. Your stomach also contains an acid, is called hydrochloric acid. And hydrochloric acid is also found in the science lab. So the uses, if you want to take a screenshot, okay, you can. Uses for this, okay, citric acid make vitamin, hydrochloric acid to clean metal surfaces. Then ethanoic acid used in vinegar. Nitric acid can be used to make fertilizers and also explosive, like bombs are explosive. Then phosphoric acid used to make fertilizer, prevent the rusting of iron. Okay, and then sulfuric acid used in car batteries is used to make detergent also. Okay, also to manufacture plastic and fertilizer. It is also commonly used as a dehydrating agent. Dehydrating agent means like a drying agent. It will remove away water content. Hold on, we have somebody who just joined us. Okay, hi, Munchin, is it? Manchin.
Yeah, Manchin.
Manchin, yeah. Hi, welcome to class. Today is your trial lesson, yeah?
Yeah.
Okay, right, I just started. So you pay attention first. I'll talk to you maybe at the end of the tutorial.
Okay.
Right. Okay, now we go on to the next slide. You need to know chemical formula of acids, and usually at your level, you just need to know hydrochloric acid, nitric acid, and sulfuric acid. Okay, this is the chemical formula, right? Characteristics of acid. If you look here, okay, it shows a hand that is actually injured, okay, because the skin, all right, has been in contact with acid. Acid is very corrosive. Okay, it has a sour taste, it conducts electricity. corrosive and it can burn the skin. All right. So if you're not careful, you come into contact with strong acid, this can happen to you. Okay, acid will turn blue, litmus paper red. This is one example. Okay, because orange contains citric acid. Okay, so litmus paper, when it comes in contact with orange juice, it will turn from blue to red. Okay, same thing here. An example. This is an acidic solution. So blue litmus paper will turn red. Even though you see pink, right? We only talk about the colors blue and red. So litmus turns from blue to red in acidic solution. For alkaline solution, the opposite happens. We will look at this later. Okay, so acids react with metals, carbonates, and alkalis. Okay. The first reaction of acid you need to know, acid plus metal, it will give you salt and hydrogen gas. This is the generic word equation, a general one. Then when you go to the specific, okay, hydrochloric acid plus calcium, how do you get the salt? The salt is actually from the metal as well as the acid. So the metal is calcium. Then the acid, in this case, is hydrochloric acid. So this is chloride. Okay, so calcium chloride is the salt. Hydrogen gas standard, all kinds of acid plus metal reaction will give off hydrogen gas. Okay, wait. Then you watch this, okay? So that is the hydrogen gas that is being collected in the eggshell. Right? So they actually crack the egg at one end, okay, tiny hole made. Then what happened is they remove the egg yolk and the egg white, wash it clean. So it's an empty eggshell. You use this eggshell to collect the gas that is being formed during this reaction, and the gas is hydrogen gas. All right. And to test for hydrogen gas, you use actually a burning splint. Okay, and that's what happened. Okay, so salt consists of two parts. Okay, one is actually the metal part. Okay, the other one is the acid part. All right, so the arrow seems to be not so accurate. Okay, so the metal part is calcium, acid part is chloride, because this is hydrochloric acid. That's why you get a chloride. Okay, how to test for hydrogen? Okay, in the presence of hydrogen gas, lighted splint. Okay, I don't want the word extinguishes. It should be, okay, there is a pop sound that's heard with a lighted splint. Because not all the time this flame goes off. Okay, just a minute. Let me show you the video as for gases. Okay, 1 minute. Okay, so you can see he actually started off, okay, he light up this splint, right? The splint is like a wooden stick. So light up the splint first, he blew off the flame, so he gets a glowing splint instead. The moment he put the glowing splint into oxygen gas, it actually reignites. That means there's a flame that's observed again. Okay? So it relights a glowing splint or reignites glowing splint. That is how we test for the presence of oxygen gas. All right, so you can actually hear a pop sound, but it doesn't put out the flame. That's why I said just now, right? Okay, I don't want you to remember the part on, okay, extinguishes the flame. The flame doesn't go off, okay? So not all the time that it goes off. That's why when you look at this, okay, look at the slide again. Observation here. Okay, now you can see my slide. Observation here. In the presence of hydrogen gas, lighted splint, okay, gives a pop sound. So let's not have this part. Okay. Sometimes it does put out the flame, sometimes it doesn't. The lighted splint gives a pop sound. All right. So that's how we test for hydrogen gas. So when an acid is added to a metal, effervescence is produced. What is effervescence? Effervescence is actually the bubbling. So just now in the video, you see a lot of fizzling, okay? The bubbles come out. Okay, that is called effervescence. A lot of bubbling. Next reaction, acid react with metal carbonates. Okay, metal carbonates or ammonium carbonates. You just need to know this part here, memorize this part enough. It will give you salt, water, and carbon dioxide gas. So generic word equation, acid plus metal carbonate produces salt, water, carbon dioxide. Water and carbon dioxide always will be formed this way. The salt that is produced, the name of the salt really depends on the metal as well as the acid. Okay, Jocelyn, we went through this part. Okay, last lesson. So you look at this example, zinc carbonate, okay, plus hydrochloric acid. What is the salt that's formed? So we look at the metal portion over here, zinc, is the metal portion, and then the chloride follows the acid that you put in. Okay. What happens when actually you put an egg in the acid? Take a look. Okay. So that's called a bouncy egg. Now, originally, see the egg with the eggshell, it is very, very hard, right? Okay. If you were to drop it, it will crack. Okay. You can't like try to bounce it at all. Not possible. The moment you put vinegar into the egg and let it soak for like 2 days, okay, or even 3 days, even better. What happened is because the eggshell is actually calcium carbonate. All right. Eggshell is actually calcium carbonate. If I put vinegar, which is the acid, into this container or this cup or glass, sorry, with the egg, the acid will actually react. Vinegar is an acid. The acid will react with the eggshell, the outer part, which is a calcium carbonate, right? Okay. And then it's going to form a new compound. So it dissolves away the outer part covering. And then you know eggshell, right? There is actually this inner layer, okay? That's like a membrane, right? So what is left will be just the membrane. So the membrane is there, okay, still holding the egg together, but now you can bounce it. Have y'all seen something like this before? Put out your hand if you did, okay? Or you can put a thumbs up. If you have not, then you put thumbs down. Have y'all seen this before? Oh, okay. Manchin actually saw it before. Good, good. Manchin, is it because you've done this topic already in school?
No, I watched it in a video.
Is it in school or your own?
On my own.
Wow, good, good, good. Yeah. So actually, yeah, it's quite fun. Done what again? Okay, Jocelyn, have you seen this bouncy egg experiment before? Okay, have you learned this topic in school? I know you did, Jocelyn. You learned it in school. You tried on your own. Did you succeed? When you were 7. Interesting. How come you did it when you're 7? In school, everybody did it oh, okay. It was an experiment everyone did for your school, No? You too. Okay. But not everybody has come across this, Sherman didn't come across this before. Azim, have you? Never also, right? Yeah. Actually, you can try this on your own. Okay. And then after the whole thing, after 2 to 3 days, what happened is, okay, when you look at the egg, you seem to be able to see the inside vaguely, not that